For each positive integer n greater than 1, let p of n denote the greatest prime factor of n. For how many positive integers n is it true that both p of n is equal to the square root of n and p of n plus 48 is equal to the square root of n plus 48? For both of these things to be true, it has to be true that 1, n must be a square, because p of n is always going to be a positive integer, so this has to be a positive integer. And it has to be true that n plus 48 must be a square, because this is always going to be a positive integer, and therefore square root of n plus 48 must always be a positive integer. So cycling through potential values of n, we'll just cycle through all the squares. So 4, 9, 16, and see if we notice anything. 25, 36, 49, 64. So one thing to notice is to be thinking of adding 48. I want to look at this term, n plus 48. So here are potential values of n. Adding 48 to each of these, and will it give you a square? So adding 48 to 4 will not, 9 will not. To 16, it's actually true that 16 plus 48 is 64, which is another square. And we can see this demonstrated by the fact that there's 9 in between here, 11, 13, and 15. And 9 plus 11 plus 13 plus 15 is 48. So now to check if both of these are true, we want to check. So we know that so for n equal to 16, first we can check, is p of 16 equal to the square root of 16? Well, p of 16 is equal to, the greatest prime factor of that is going to be 2, and square root of 16 is 4, so that is not true. So already we can rule out 16 will not be. So keeping this going, we can see if we notice any patterns here. 100. So if we look at these numbers that are the difference, it's going up by 2 each time. 19, 21, 23, 25. And so, yes, you can add 48 to each of these, and you'll find that when you add 48 to these, the only one that is a square again is when you jump from 121 to 169, and we can see 23 plus 25 is 48. So it's true that 121 plus 48 is 169. So let's check that one. So first, p of 121 is equal to 11, and square root of 121 is 11, so that checks out. And then is it true that p of 121 plus 48 is equal to p of 169, which is equal to 13, which is equal to root 169. So this one works. when n is equal to 121, that is one case where both of those are true. And again, we can go back to this, and one thing to notice is we went through two squares to get to 169. In other words, there was one square in between 121 and 169. So for the next square, it should be that we have some number x and then some number y, and the difference has to be 48, because this difference is only getting bigger because it's growing by 2. And what I mean by that a little more clearly is when we get to these bigger numbers, for example, 484, talking about bigger squares, 529, 576, 625, where this is equal to 25 squared, 24 squared, etc. The difference between these is 45. The difference between these is 47. The difference between these is, this is 49. So the difference between squares will never be 48. The difference between two squares will never be 48. Therefore, n plus 48 will never be a square when n is greater than 121, because this difference is only getting bigger. So n plus 48 will never be a square. You'll never be able to get to the next square because the difference will be getting bigger. N plus 48 will never be a square when n is greater than 121. So since we've concluded that, obviously this will never be satisfied when n is greater than 121. So this is the only case. When n is equal to 121, that's the only time when this is true. So for how many positive integers n is it true? The answer is 1. So the answer here is choice B.